Okay, so what we're going to look at today is how to find the area between two regions. And we've talked about this a number of times, that if we have a region set up here and we take this integral, and let's just say that this is going to be from 0 to 1, and this function is f of x, that the integral, the area, is going to equal to this integral from 0 to 1 of f of x dx. And that would just show this region right here. Now, again, we've seen that several times, but let's look at a little bit of application here. What happens now if I come in with a function g of x? If I come in with a function g of x, and I let g of x, let's just almost make it a sign. Of course, the sign wouldn't cross at 1, but let's just do something similar to that. And now say that we want to find this area right in here. Well, if you think in terms of what this is, the area that I've got represented here is the area between this top curve and the area of the bottom curve. The area of the top curve, taking away this area right here. That would give us this region. So the area for this would be from 0 to 1 of f of x and we're going to take away from that the area from 0 to 1 of g of x. And I can show that region as this region right here. So if we take this area of f of x, take away the area that's in brown here, which is represented by g of x, we're left with this area between this region. Now we can write this in terms of one integral by using our properties of integrals, saying that if we subtract two integrals, it's the same thing as subtracting the functions and taking the integral of that. So that's how we're going to go about finding the area between two regions. So, a few other things can happen here. And I'll try to get away from that blue marker because the blue marker was not writing too well. So, we come here, and let's just say that we want to know the area in the first quadrant between f of x equals x squared and f of x equals the square root of x, or g of x. We need to call it two different functions. So we want to find the area between those two graphs. Well, if we take the graph of x squared, and I'll do it in blue, like I said, I was going to get away from using blue. But that area comes right here. And then the area of the second curve, and I'll do it in brown, comes right here. So this area of the region that we're looking for right here is going to simply be this region right in here. Now, how can we find the area inside of this region right here? Well, we're looking at the graph here, and from looking at the graph, I know which one is in top in the region. It's the square root of x. So I would be taking the integral from, well, I haven't set up my lower, I know my lower one's going to be 0, but we're going to solve for this in just a minute. Square root of x minus x squared dx.